Okay, so there's basically just a couple of things, or not couple, there's several things that I want to talk to you about. This just kind of like good pieces of information to know. So I'm going to teach you, we haven't learned how to put references in a LaTeX document, so I'm going to show you how to do that. And then as I do that, I'm going to show you two other things. I'm going to show you something called MathSciNet. I'm going to show you something called it's a database called MathSciNet, and it's connected to these to what I'm talking about with references. And I'm also going to show you something called the ArXiV as well. Both the MathSciNet and ArXiV, sort of the primary ways, as well as just Google searching, to find papers and articles, math papers and math articles, things like that. So for those of you who are going to be doing a, so if you are working with me as your chair in the master's program, typically I'll have you read a paper. And using something like MathSciNet or ArXiV, this is something that will work out well. Okay, so so as far as I know, there's basically two main ways to put references in a LaTeX document. One is AMS Refs, that's American Mathematical Society. We're using a lot of their packages. And one is BibTeX. I don't like BibTeX. I'll show you why I like AMS Refs. Now, whenever I'm writing anything, I do AMS Refs. The only time I ever do BibTeX or anything else really is if I'm submitting it to a journal and the journal wants something specific, which doesn't happen very often. So for me, really, AMS Refs is the only game in town. So AMS Refs, have to add that into your user package here. Here is information about AMS Refs. So this is the PDF. You can just Google AMS Refs and get the documentation here. Come back over here. Again, since we're doing everything in Overleaf, we don't have to put any packages there. We don't have to do anything. Everything is automatically there. So because I have these two items right here, begin bib div and begin bib list, it has this references pop up over here. Obviously, there's nothing here, so we can't have anything. Okay, so now MathSciNet. Here's how I access MathSciNet. I just Google TAMU MathSciNet. I go to databases here. There's probably much easier ways to do this, but in my mind, I know this works, so I haven't figured out anything else. And then I scroll down here to MathSciNet. Now, several years ago, they changed the interface, and probably what you're going to see is something like this, but I like the classic interface. So I'm going to just look up some papers here. Let's say in keeping with our reading, I will find an article by Steve Krantz. I don't know why I'm picking him. Is he a V, Stephen? Ah, yes, he is. Okay. So what do we have here? Okay, so here we got this. Now let me find an actual article. Okay, so here's an article. Sorry, for some reason I want a different. Okay, here we go. Whatever this is. Okay, so if you look at it, this is the title: Continuous Dependence of Zago Kernel on a Weight of Integration. These are all of the authors. This is the journal, Complex Analysis and Operator Theory. This is the journal edition, the number, all of that stuff. Okay, so even if we're not talking about AMS refs, if I click on this, it'll come to this, and now I have several different options. If I want the article, I can click this, and it's going to give me different options. I can go find text at TAMU. As students at TAMU, you should be able to have the same access that I have. And so online copy available here, and you can get to the article. Okay, now you can get to the article. Okay, so here it is. All right, so that's that. So that's how you can search for articles. Of course, there's other search fields, and you can figure out, how, depending on what you want to search, you can figure out what to type. The other thing that I want to show you. So, hold on. Let me get to another article because this doesn't. Let me get to an older article. Hold on. Okay. So, what you have here. So, same thing before. What you have here is a review of the article. So here, depending on who writes it, some of the reviews are longer than others. This is a pretty long review. Typically, it's about a paragraph long or something like that. especially for such a short paper. This looks like it's only 17 pages, and it's a very long review. So it's typically less long than this, but at any rate, this will give you an overview of the paper to see if it's something you might even want to look at. Some other stuff that we have here, sometimes, and I don't exactly know why it does this sometimes and why it doesn't and other times, there will be a list of references down here that it uses that you can also click and link to. I think the first one that I saw, let's see if this one has. Okay, so here are the references that are listed. So, okay, so let's say you want to look at the, so this is probably actually a pretty interesting article to read. I'm actually going to download this. Sorry. It looks interesting and I want to read it, so you're just going to have to deal with me for a second. And now you can look again at how I can, see, it's a good teaching moment. I can teach you how to find things. Okay, so if you don't know what the Riemann Mapping Theorem is, here we go. It basically says if it's a complex analysis theorem. It says if you have a domain, an open connected domain in the complex plane, then it is a conformally equivalent to the disk or the upper half space, meaning there's a conformal map that goes between the two. Now, most of the proofs involve a lot of like very sort of high-level complex analysis. So I'm interested what this is. And at any rate, okay, that was completely tangential there. Okay, so what we have here is a set of references. Now these are the references that are in the paper that Krantz wrote, and here you have a much shorter review too. I see. So let's say you're interested in this reference here, or this is a book. Let's say you're interested in this reference here. You can click on this, and now you're back to this page for that referenced paper. Okay, so this is very well. Oftentimes, what will happen, you're reading a paper, and it'll reference something, and instead of having to look that up, you can just follow the link here. Then you look at the paper, and you look at that paper, it references something else. You can just follow the link from that page, so on and so forth. So it's just very practical. Okay, now back to references. If you want to cite it, the worst way, I mean, I shouldn't say the worst way, but a very difficult way, or not difficult, but a very annoying way would be to somehow go to your LaTeX document and type in everything here that you need to have typed in, all of the information that you need to have typed in for this paper. Or you can come over here to cite, and you have different options. Here is what the BibTeX code looks like. Which is new. I don't think they used to give you the bit. So maybe BibTeX would be better to use now, because it seems like they didn't used to give you the BibTeX code. You would have to go in and type everything yourself. Here I'm going to go to AMS refs. And these are also other references as well, EndNote, and I don't know. Okay, so I use AMS refs. I'm going to copy this, close, come over here, and paste it here. Okay, so let me explain what's happening here. This right here, this is the math review number, but whatever goes here is going to be how we can reference it above. So I'm going to delete this, and the way that I like to do it, this is just my convention. I like to do the first 3 letters of the author's last name, followed by the year. Okay, you can do it however you want to. Also, I typically will I'll delete those things there. One thing that I have found in mathematics is that there's no APA or MLA or any of that sort of thing that we have to worry about. Okay, because AMS refs is going to take care of all of the formatting. If you submit a paper to a journal, they're going to tell you whether to use AMS refs or BibTeX or whatever. Maybe they have their own thing that they want to use, and they'll handle it all in-house. But basically, all you're going to do is just give the program this information, and then LaTeX, either the AMS refs package or something else, will display the information that you want. So, for example, if we come, I'll actually mention something. I'll actually mention something about the references in a minute. Okay, so now if I compile this, we're gonna have this reference here. Okay, so now let's say we want to cite it up here. So how do I refer to this reference? I mean, one thing I could do is I could say as Krantz wrote in, and now I could do 1 is Krantz wrote in 1, blah, blah, blah. If I run it, okay, as Krantz wrote in 1, okay, so you're reading this, you go down to the references, you have this. Okay, but again, what's going to happen, so this is arranged, it's not arranged in alphabetical order, it's arranged in whatever order you put it in. So if you put like an author down here with an A last name, it's not going to rearrange it for you. Okay, so let's say you come up here and put an author with an A, now it's not going to say 1 anymore, it's going to say 2, so let's see if I can do something like this. I will find my colleague here because his last name starts with a D, and I know that's before K. Okay, so I'll come down here, cite, go to AMS ref, copy that, come down here. Again, I just only like to go up to pages. And now I'm going to do, okay, so there's 3 authors, so I would do BASGELHAN, and then this is 2023, so something like that. Okay, so now if I run this, what's going to happen? Well, the Krantz says 1, but now we have the 1 here in this wrong paper. Okay, so instead what we do is there's a command in AMS refs, cite, and now I'm going to do Krantz 2023. Okay, and now when I run this, 2 things are going to happen. Actually, just 1 thing is going to happen. Sorry, I thought there was going to be something else that was going to happen. At any rate, now it says 2, which matches up with this 2 here as well. And then if I get rid of this one and recompile, now it goes back to 1 because this is a 1 here as well. Okay, now the last thing that I wanted to talk about was the ArXiV. So you might have seen this before. This is ArXiV. So I'm going to go to archive.org. And now what we have here are several different headings: physics, math, computer science, and you can read the rest. Obviously, I'm going to be looking in the math one. Now, underneath the mathematics heading, there's all of these different subfields. So the one that I check most often is going to be the classical analysis and ODEs. Now, what happens, nowadays, essentially everybody who writes a mathematical paper, they upload it here to the ArXiV first. So this is kind of, it's not peer reviewed or anything like that. You have to have an @edu email address to post things here. But at any rate, it's pretty much almost anybody can post something here. And so it is where most people put their research. In fact, I don't know of anybody below, like 70 years old maybe, who does not first post their paper to ArXiV, and then they submit it to the journal where it's peer reviewed and that sort of thing. On the other hand, if you are writing a paper in an area that a lot of people care about, people will look at it and they will send you comments, and you could definitely, I've had this happen where you have a mistake in your paper, and before it even gets to the journal, people are telling you the problems that you've made, which is a good thing to do. This is sort of just how the community works. Okay, now the thing that I want to show you 2 things. So I'm going to click here on the PDF, and if you come down, you can look at all of the different references. So here, this looks like it was probably made with AMS refs, and notice it doesn't have all of that other information. All of that information that I deleted is also not included here. So it doesn't have, all of this stuff, the ISSN. It doesn't look like it has the review number, the DOI, anything like that. If you look there, it kind of ends with the year, and these look like issue and page numbers or something like that. Okay, but the next thing that I want to show you, if I come here, so this is good if you want to look at examples of LaTeX. This was actually how I first learned LaTeX. When I was a grad student, my advisor had me, I was working on he gave me a research problem to work on. It was based on one of his papers, and once I had kind of was the point where I needed to type it up, I don't think I knew what LaTeX was at that point. I don't remember. But he said, well, here's what you do. You're going to just look at the paper that I wrote. You're going to go to the archive where the paper that I wrote is, and you're going to look at the text source, and you're going to work off of that. So you can click here, text source. It's going to download a compressed file here. So you're going to have to uncompress it, and within that compressed file, so I think I should be able to at least show you the folder. Yeah, okay. Well, okay. At any rate, it's going to have a compressed file, a compressed folder, and once you open it, there will be a .tex file that has the source code, and you can look at that and use that to help you with LaTeX if you want to. Okay, I think that's all that I want to have in this video. I just wanted to show you a few tricks and tools that you might not have seen before.